Hello everyone, welcome back to another math video. In this video we are going to talk about the z-score. The z-score is a value that will tell us how many standard deviations away from the mean a particular number in our data set is. Z-score is not going to have any units associated with it, it's just going to be a number. And we could do this for every number in our data set, and what that would do is standardize the values in our data set. So let's look at what that formula looks like. The z-score is the data value minus the mean divided by the standard deviation. So if we're looking at a population, we could write this formula this way: x minus the mean divided by the standard deviation. Notice I'm using a population notation for the mean and the standard deviation. If we're looking at a sample, it would be x minus the mean of x bar divided by the standard deviation, which is s. So one of three things is going to happen when we compute this. We're either going to get a score of 0, we're going to get a negative z-score, or a positive z-score. So let's look at what that's going to mean. And we're going to come up with just a really easy example here. Suppose our mean is 2 and our standard deviation is 3. And let's say we're looking at the x value of 5. So our z-score would be x minus the mean divided by the standard deviation. So I'm going to get 5 minus 2 divided by 3. And 5 minus 2 is 3. And 3 divided by 3 is 1. Now, notice we ended up with a positive value here. And that's associated with that x value of 5. And what that means is that our data value is larger than what the mean is. And we can see that with this example here. So this output that we get, this z-score, tells us how many standard deviations away from the mean the value is. So that tells us that the value of 5 is 1 standard deviation above the mean. Okay. And that makes sense if we were to think about these numbers. So our mean is 2 and a standard deviation is 3 units. And if I move 3 units, I get to the number 5. So this is 1 standard deviation above the mean. Let's look at another value. Let's look at -4. And we want to find the z-score associated with that. So our formula works the same way: data value minus the mean divided by the standard deviation. Data value minus the mean divided by the standard deviation. So I'm going to get -6 divided by 3, which is a -2. So what that's telling us is that the data value of -4 is 2 units below the mean. Below because we ended up with a negative value. Instead of saying units, I'm going to say standard deviations, because that's what this is really measuring. So if I go back to my graph over here and I move standard deviations down, so if I take 2 and I move 3 units down, which is 1 standard deviation, I'm at the value of -1. And if I move another 3, I'm at the value of -4. So you can see how that -4 is 2 standard deviations to the left of the mean, which we would say is below the mean. So let's look at another couple of examples. Suppose we're looking at human body temperatures. They tell us that there is a mean of 98.2 and a standard deviation of 0.62. And we want to convert each of these to a z-score. So our z-score is going to be the x value, which is 101, minus the mean. We're going to divide by 0.62. So I'm going to do this on my calculator off to the side. So 101 minus 98.2 is 2.2. I'm going to divide that by 0.62. Yeah, hold on 1 second. I actually typed that in wrong. 101 minus 98.2 is 2.8. And 2.8 divided by 0.62 gives us 4.52. So this would be 4.5 standard deviations above the mean. And if I were to look at that next one, the z-score would be 96.90 minus the mean, 98.2, divided by the standard deviation. So I'm going to get negative 1.3 divided by 0.62. That's going to give me a negative 2.10 when I round to 2 decimal places. And then if we look at that last one, we've got 96.98. So my z-score would be the x value minus the mean divided by the standard deviation. Got negative 1.22 divided by 0.62. I got negative 1.97. So we would say that x value of 96.98 is almost 2 standard deviations below the mean. 96.90 is a little over 2 standard deviations below the mean.